Okay, so first of all, we got to copy down this data set. This is kind of cool. We're going to do this one. So if you're interested, this is an actual data set, and this is telling us the average speed of the space shuttle after this many seconds after launch. Okay, that's what we're looking at. All right, so we want to use our calculators here as tools to represent and explore and model this data. Okay, so let me do something real quick here. Okay. So let's just start at the home screen. Anybody know where we go to input data? Stat. Good. We're going to go to the stat screen. There are 3 menus on the stat screen. We got the edit menu for inputting, mainly for inputting data. Other stuff too, but mostly that. Calculate menu, which is all of the regressional models that we won't use them all, but we'll use several of those today. Those are to fit the data to a mathematical model. And then these we won't use. These are evidently, if I look at these, they're tests of validity and various statistical tests that are kind of higher order things that we're not really going to deal with. This is more complicated. So we're going to go edit. Okay, edit takes you to this screen, which is like a spreadsheet. L1, L2, L3, etc. L stands for list, and that's where you're going to put the data for the various different quantities that you're going to plot. And then what we always want to do is we want to put the X data in L1, so that's where our independent variable goes, and the Y data goes in L2 because that matches the defaults of the calculator. So this is old data. Let's get rid of this. Now, how do you do this? You go to the top and you want to hit clear. You go to the L2, so you're at the heading of the whole column, and you hit clear, enter, and it gets rid of your column. Okay, now what happens if you go over and you try hitting delete, and uh-oh, what happened? Deleted the whole column. So if I go to the left, it's still not there. If you do that, you just have to go buy a new calculator. All you have to do is go back to stat, and then in the edit menu where it says set up editor, if you go down to number 5, and then execute that, so it says done, and then go back to stat, edit, voila, it gets you to your column back. Okay. So to get rid of it, to clear it, we just go to the top, clear, enter. Okay. Now we want to put in this data. X is going L1, Y's or f of x goes in L2. The easiest way to put this in is just to, after you input a value, you just hit enter and it drops it down to the next place in that column. Okay. So 10, enter, and go ahead and put all this in. 20, enter. 30, enter. Does anybody not have a graphic calculator to use today? I have access to some, but I haven't gotten it yet. So if you don't, that's fine. You don't really need one. Just get next to somebody and kind of somebody, buddy up with somebody so you can see what's going on. And this will be published, so you can see this and get on there and do your homework. I can maybe even see if I can get some at the end of the period, so I can. How are we gonna do that? I don't know if I can check these out or not. I'm not sure. I have to ask. Is anybody? Are you guys? I mean, I would recommend highly that. I think in this class especially, I know they're not cheap. I think they're $88, but I think this would be a really good thing to maybe talk to your parents about, as if you don't have one, about getting one. It's, we can get by without it. We'll find a way if necessary, but I really think it's going to be a lot easier for you if you actually have one in your possession. Anyway, keep going. Okay, so hit the right arrow, it bumps you up to the top of the column.
Speed was measured in kilometers, right?
I think it's measured in meters per second, I believe. I would guess. Oh, feet per second. Feet per second, okay? Got them all in there. I always kind of do a quick check to make sure I've got the same number of entries in both columns. So if I don't, I know I messed up. This doesn't mean I did it right, but at least I still could have put something in inaccurately, but at least I know I got the right number. Okay, now what? If I want to do a scatter plot of this, which is a good thing to do so I can actually see the data. Okay, to do that, I've got my data in. Now I just have to make sure that my stat plot is set up. And I'm sure it is, but we'll just check once to make sure. So just go second, stat plot, and that gets you to the stat plot menu. It looks like I've got 3 of them that are already set up, and then 2 that I haven't used. If we go into the first one and I just hit enter, it opens up that first stat plot so I can change any of the settings that I want to. But notice that the defaults are the ones that we want. The defaults are scatter plot, and there are a bunch of other other different kinds of stat plots we can do. We can do a line plot. We can do a bar graph. We can do box and whisker plot with outliers, box and whisker plot without outliers. We can do, all kinds of stuff. Mostly, we'll use the scatter plot. X list is set to L1, like we expected. Y list is set to L2. The mark is set on the box, which is the best one to use. The other ones are too hard to see. And unless you have a color calculator, you wouldn't have this last option, but it's not a big deal. So that's all good to go. Hit enter. I guess I actually just hit escape maybe, huh? Quit. And is it on? Okay, yeah, if I go to Y equals, I can see that plot 1 is on, right? Okay, because it's highlighted, which is good. And so then, if I just hit graph, it's probably not going to be very good because it's I'm at the mercy of whatever the window was set up last time. I've got to get the windows set to match the data that I just input. That sounds like a big job, doesn't it? It's easy. Watch. Just go to the zoom menu, and I'm going to choose zoom stat. So zoom to get to the zoom menu, and then press a 9. Look what it does. Okay, pretty cool. Gives me a visual representation of the data. Okay, that looks sort of straight, doesn't it? But it's got a little bit of curvature towards the end. All right, so let's explore some different, we're going to look at polynomial regressional models today. There will be some instances this year when we're going to want to look at maybe some different kinds of regressional models, but usually we want to look at polynomial regressional models. What's a first degree polynomial? So the biggest exponent is 1, right? So what else do we call that? It's a polynomial where the biggest power of x is x to the 1. That's what? What is it? No. No, you're making it harder than it needs to be. It's a line. Yeah, it's a line. So a first degree polynomial would just be what we would call a linear regression. Second degree polynomial, what's a second degree polynomial also known as? Okay, yeah, it's a quadratic function, right? A quadratic polynomial. So that would be a quadratic regression. Third degree would be a cubic polynomial, right? And so that would be a cubic regression. Fourth degree is quartic, and that's as high as the calculator goes, as much as frankly we'll ever need. Okay, so let's go then to stat, calculate. Here's our list of all the regressional options that we have, and there's even some more below that. But the ones we need are all on this page. Let's choose number 4, linear regression. It looks like we even have the option, of doing ax plus b or a plus bx. Let's do ax plus b, so it looks like nx plus b. I've never even noticed that other one on there, honestly. Okay, so what do we have to do? Well, not much. X list is L1, check. Y list is L2. We could just go down and hit calculate, and it would give us the equation. Oh, there's one other thing I forgot to have you guys do, real quick. Go to mode. And then if you go all the way down where it says stat diagnostics needs to be set to on. Okay. Okay, so stat diagnostics is on. Once you get that, we can just quit and go back to stat calc 4. Stat calc 4 gets us to linear regression. We're going to go down, and we could just go to calculate, but instead we're going to stop at store regression equation. We want to store this regression equation as a y variable, so it will graph the actual regressional model for us. Okay? There's a shortcut to the y variables. You can get to them by going through the variables button. You can go variables, y variable, or y, I can't remember the strings. You go variables, function, y variables, and then y1. But you don't have to do that anymore. You used to have to do that. Now you can just go alpha, and these 4 buttons are shortcuts. I think it's the 4th button, so it's alpha F4. I don't know why that one's missing, but there should be. I think there's supposed to be 4 of those things up there. And this takes us right to all of the available y variables. So we'll just choose 1, y1. We'll go down and hit calculate, and it's going to think for a second. And then it gives me the answer. Okay, here's what it tells me. It tells me that the best fit line has, in the form ax plus b, where a is the slope and b is the y-intercept in this case, has a slope of 27.92 roughly, and a y-intercept of roughly negative 121.48, it looks like, something like that. Okay, make sense? That's pretty good. Notice that you all, did it work on the calculator too?
Put the things in.
Oh, which things?
The numbers.
The numbers?
Yeah.
Oh, okay. Did it give you back a regression though?
Yeah, it did.
Okay.
It's not better.
Okay. Okay. I'm real curious to see if it gives you the same. I think it will. I'm pretty sure it will. Everybody got, if you put, what's that? Did yours not look like that?
No, mine
But it does, okay. Oh, you have it on yours, but it did do it on your I got it on your calculator. Good, okay. So, or on your phone. So everybody got the same answer as long as we all put in the same data points. That's important, isn't it? Now, do you remember going back to, I don't know when it would have been, like in Algebra 1 or something, probably back in middle school. Do you remember making a scatter plot and drawing a best fit line and all that stuff? What's wrong with that? It's sloppy. Not everybody's going to get the same answer. There's a ton of human error built in. And the fact that we all get different answers makes it not nearly as useful. This way we can all agree that based on that data, this is the linear model, right? This is it. It's called least regressional squares. That's the algorithm that's used, and it's in most cases the very best way to do it. Now look what it actually did. If we go graph, there's the line that was produced. That's pretty good. What do you notice about that line? It's straight, it's a line. But look how it matches the data. It matches the data in a way where it goes right down the middle in a way where, you know, roughly half the points are above and half are below. Does that make sense? If we go back to the stat screen, there's something else I want to point out with that. So stat, cal, for, calculate. And notice the other numbers that came up there. So these are the slope and the y-intercept. There are some other numbers here too. The r is what's called the correlation coefficient, and that's really just the slope of the line. And then r squared, this is called the coefficient of determination, but a lot of times people just talk about it as r squared, and we all know what we mean. That is an important number. That is essentially telling us how accurate that model is. What percent of the, it's kind of difficult to say exactly what it is because this is a little bit hokey, but you can think of it as saying that our line was 98.2% accurate. That's how well the data fit our line. This is a number that statisticians actually call the goodness of fit. I don't know why they use it. It doesn't sound grammatically correct, but it's called the goodness of fit. And that is pretty good, 98%, okay? Let's try another one. Let's just see what we get. Let's try a quadratic model. So let's go back to stat, calculate screen, and go down to number 5, okay? And we'll just store this one as y2. So go down to the store regression equation, alpha F4, and we'll choose y2. Is it doing it? There we go. Look at this one. This one is over 99% accurate. Wasn't the last one like 98 point something? So it improved. Okay. Drag screen, what does that mean? It's like I'd build this up there. I guess not. So let's graph it and see what that looks like. There's the scatter plot. The blue curve is the line. That's the linear regression model. The red curve is the quadratic regressional model. Okay. Do you see why maybe that fit a little better? Doesn't it seem like it matches the data points just a little bit better? That seems good, but we'll talk about it. Okay, so let's go back and do another one. Let's do cubic also. So number 6, so stat, calculate menu 6, store it as y3. .92% accurate. It's getting right up there. So that's, wouldn't you expect that then to just about match every point pretty well? There's the linear. Pretty good. There's the quadratic. Pretty good. There's the cubic. Even better, right? Okay, let's go ahead and do quartic too, just to see what we get. So stat, calc, quartic is 7. Let's store that as y4. Okay, 99, that last one was 99.92, 99.97. So it got a little bit better, a little bit better. See if we can notice much of a difference. There's the cubic. There's the quartic. I guess it's pink. It's getting all pretty jumbled up, isn't it? Okay. So what's better? All right. Well, what the question actually asks about here, I didn't read the last part of this. It says, when the space shuttle reaches a speed of approximately 4,400 feet per seconds, its booster rockets fall off. Use the model to determine how long after launch this happens. All right, so now we need to extrapolate this out there, right? We're going to make an estimation, and we call an internal estimation. If I want to make an estimation of a value that's within my data set, I call that an interpolation. Let me write that for you. If it's inside my data set. If it's outside of my data set, we call it extrapolation. And that's the part, the inside part is, all those did a pretty good job. I mean, probably the curvy ones did a better job, but here's where here's where really we give these regressional models a workout, is when we do extrapolation. So let's go in here and let's go ahead. We don't really, in this case, we don't know how far to go, but we'll just make a guess. What if we say something like, let's look at our data and just make an estimate here. So we went out to 80 seconds and it was only there. So what if we go out to, like, I don't know, 140 seconds or something? Let's try that. So if I go up to my window, which sets the size of the window, and I'm going to make my X max 140, to get the screen to stretch vertically to match my horizontal size of the window, I can go back to the zoom menu and choose zoom 0. 0 is the next option down. You can't see it. It's called zoom fit. You can either scroll down, but I always just hit zoom and then type a 0. And it's thinking. It'll do it for me. So there's my data set. There's the linear model. Probably not good, huh? It needs to be rising a little bit. Okay, there's the quadratic model. There's the cubic model. And here's the quartic model. Okay, so what do you think? How do you know which one to use? Could we discard the linear one for that, do you think? Seems like it was off a little bit, right? The quadratic one, do you remember what the fits were? The quadratic one was like 99.2, I think. And then the cubic model was 99.92 something. And the quartic model was 99.96 or something like that. So would you agree we made significant jumps going from linear to quadratic, made a pretty healthy jump from quadratic to cubic, but after that it didn't change very much, right? The cubic was pretty good. Here's our rule of thumb. What we want to do is we want to use the least powerful regressional model that does the job adequately for us. The reason we say that is because the more powerful the regressional model gets, the more apt the model is to jump around too wildly, and that's not good for a statistical model. This example, wasn't, honestly, the quartic wasn't terrible. I was kind of hoping the last example we used last period, which I'll put that video up if you want to just look at some of the graphs on it or something. It was really bad. On the last one, the linear model was the best model. When we extrapolated a little bit with our, in fact, I wonder if I should have taken screenshots. But I mean, it went all over the place. We were looking at housing prices in the Northeast, and the prediction was, I think, let's see, in 1995, the average price of a home in the northeastern part of the United States was $180,000. In 1987, the beginning of the data, it was $140,000. So it went up, a little bit, 40,000 bucks. But then if we extrapolated that up to 2005, and we live in 2015, so we can tell whether or not this is accurate. The Quartic model had the average average home price in the entire Northeast being close to $1 million in 10 years ago. That's not right. I mean, sure, there are some mansions there, but the average price of a home, no way. That was way off, right? And so even the cubic was like 800,000. I mean, way too high, right? And so we could see that they were just too aggressive. They didn't work well. They jumped way off the charts when we started to extrapolate. So they were no good. The linear one was the best model. The quadratic one actually went down, which didn't happen either. So in this case, so what do we think? The cubic? Makes sense? And you see the reasoning for that? Because it was significantly better coefficient of determination than the other two, but you didn't jump up much after that. So we want to go with the cubic rather than the quartic, right? So let's do the analysis here. We want to know, this is also kind of good practice. Let's just say hypothetically that we wanted to know how fast it was going after 120 seconds. Time is on the horizontal axis, right? And speed is on the vertical axis. That's easy to do. We can use that trick did we do this in class the other day? That was calculus, wasn't it? Okay, so here's a good trick. If I want to know what the value of a function is, I can just go trace, and then, excuse me, and then up here it's going to tell me which function I'm currently tracing on. Well, this is the scatter plot. We don't want that. So I hit the up and down arrow to jump from function to function. So if I hit the down arrow, it jumps me to y1, which is the line, correct? So if I want to know the value that the line predicts after 120 seconds, then I would just type in 120 after I've already hit trace and picked my curve, hit enter, and it puts me right there, and look what it tells me. It tells me the x value is 120, which we chose, and the y value is 3229. That's how many feet per second it predicts it would be going, okay? Too slow, that's not right. We wanted to use the cubic one though, so let's go trace. We'll hit the down arrow until we get y3, because that was our cubic, right? Then we'll hit 120, and that tells us it's going 6,226.6 feet per second. Okay, but what we want to find, remember, is where does the function, or excuse me, how long does it take for this thing to get to, was it 4,400? That's when its booster rockets fall off, 4,400. So how are we going to do that? The calculators aren't built to do that directly. We can put in an x value and find a y value, but how are we going to input a y value in order to find an x value? It's a good trick. Here's what I would do. Let's go back to y equals, and let's unhighlight, so turn off all the functions that we're not using, so we can declutter this a little bit. So let's turn off y1, turn off y2, and turn off y4, because we're keeping y3, right? Or you can delete them if you're not going to use them anymore. Then let's go up, and we can leave the plot on, that's probably fine. We went too far though, so I'm going to make the window, let's just make it go back a little bit. Let's make it go back to like 130, how about? And I'm going to go zoom 0 again with just those two things, just the scatter plot and the cubic. Look how well that fits, that's pretty good. Okay, here's my trick. Let's go into y equals, and let's go down and create a horizontal line at what value? 4,400, right? Because that's what we want to do. We want to find out how long does it take to get to that speed, right? So we'll type in a horizontal line, so y6, or y5 in this case, y equals 4,400. Let's go ahead and hit graph. So where on the graph is the point where the space shuttle is going 4,400 feet per second? Yeah, at the intersection, right? When our cubic model gets to a height of 4,400, when it intersects that line, that's going to be the place we're looking for. So all we have to do then is we can go to second calc, and that gives us all the tricks we can do with our graphs. Which one of those do you think we want?
5.
Yeah, we want intersect, so we'll go 5. We have to choose which lines. So the first curve, is it y3? Yeah, it is, right? So we hit enter. Is the second curve y5? Yes, it is. So we hit enter. Otherwise, we'd have to use the up and down arrow to change that, right? And then it wants a guess. Well, we don't even have to put a guess. If it's just two curves like this, if they only intersect once, it wants you to kind of take it over there and place the cursor close to where it actually happens, but it'll find this so easily you don't even have to. There it is. Okay. So the intersection is at 106.096 blah 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 4,400. So how long does it take based on our model? Yeah, about 106 seconds to get there. Pretty good, huh? You see how that could be pretty useful? Okay. What I want to do with this, I would like to, this is a difficult one. Honestly, I've decided I don't really care for this textbook very much, but maybe it'll get better. I don't like the problem, but I'll be building most of the problems anyway, so it's fine. They talked a little bit about this, and you're welcome to read that section. Probably should. I want to have you do a little practice with this, though. I think we won't start with actual physics stuff until next week. I think you guys have worked really hard. I'd say just take Monday off. We'll just meet on Tuesday. How about it? Why don't you, I haven't put anything up there yet, but I did a ton of programming last night, and I built a regressional engine for Moodle that'll I can use to make some questions like this. So what I'd like to do maybe, and you tell me what you think about this. I want you to get a little practice with the calculator, so I'm maybe going to give you a couple problems where I give you a data set, not a lot because it's time consuming, but I'd like you to go in and maybe calculate what the regressional models are, what the it gave you the equation, it gave you the coefficients, right? I want you to tell me rounded to so I'll tell you how many places, rounded to maybe 4 places or something. Tell me what the actual regression equations are for a linear model, quadratic, cubic, and write those down. And then I want you, and give me the R squares, okay? And then that'll just be kind of a cut and dried, either right or wrong question. But then I also think I want to give you something that's maybe more open-ended, that won't even get self-graded, that I'll have to go in and grade. Where I'm going to give you a situation, just one or two. I don't want to waste all your, I don't want to take all your time, it's going to be time consuming, but I want you to think about this. Where I'm going to give you a data set, kind of like a mock data set, and I want you to investigate this a little bit. And just, you don't have to write a whole book about it, but actually discuss it and kind of tell me, okay, this is the model I think fits the best because, and give me an explanation, kind of based on the stuff we talked about. And I'm going to think about this over the weekend, but maybe this would even be the kind of thing where we could get together in some groups sometime next week in the lab, and I could assign some groups, and you could bring this stuff in